Hi, in this video, we will see bitwise operators in Java. Okay, so what are those bitwise operators? So, which can be applied to the integer types long, short, char, byte. So, but this is and A and B copies a bit to the result if it exists in both operands. Okay, so or if it exists only either. Binary XOR operator copies the bit if it is set in one operand but not both. Okay, so till the A binary one's complement operator, this is okay, is unary and has the effect of flipping the bits. So it's if it is 1, it will become 0, something like that. 0 will become 1. Left shift operator, the left operand's value is moved left by the number of bits specified here. Okay, right operand, the same thing, right shift. Okay, so here it will not be very clear, but we'll see these binary values we need to take for each and everything. Okay, so let me go to will explain the same thing here by some examples, then we'll write the program. Okay, so here let me take two values. So two values, A is equals to 4. Okay, one second. So let me take A is okay, let it be. So A equals to 4, B equals to 5. Okay, so we need to represent these values in the binary. So 4 value is in the binary 0, 1, 0, 0. For the 5, the value is 0, 1, 0, 1. How it will be represented? So the binary will be 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, something like that, right? So 2 to the power of 0 means 1, 2, 4, 8, then 16, something like that, it will give you. So now here, A is equals to 4, how will represent? Okay, so let me take 4 bits is enough. Okay, 4, 8, 4, 2, 1. Okay, so A is equals to 4 means, so whenever you need that value, that will become 1. So remaining things 0, 0. You see that same thing. Means in the one area, what is that? 4. That's how it will work. Now B is equals to 5. 5 means here 1, this is one value, right? 1, 4, 1, 5. So 0, 0. So 0, 1, 0, 1. Okay, this is how you will represent. Okay, now A and B. Okay, A and B. Here, what I need to do, let me take this one. Now A and B. What is A and B? In both the values, if it is 1, then it will become 1. Otherwise, it will not. So 0, 1 means 0. 0, 0 means 0. But 1, 1 means 1. Both 1 means 1. Apart from that, everything is 0. 0, 0 is 0. So now A and B became what? 0, 1, 0, 0. In the 1 position, what is there? 4. So it is 4. A and B equals to 4. This is how you need to calculate. Okay. And now the second one is A or B. Right. That is what we have seen in the table. Now A or B means any one of the value is 1, then it will become 1. Now 0, 1, 1, 0, 0, 0, 1, 1, 1, 0, 0, 0. Now one position is 1, this one position is 4. 4 plus 1, 5. Right. A and B became 4. A or B became 5. So this is how you need to calculate these bitwise operators. Now that is, what is that another one? Let me see that. You see that A XR. Okay, A XR. Sorry. So here, what happens? It will reverse the values. Okay, it will reverse. Sorry, what happens here? Now, if any one of the value is 1, if both are same, it will give you 0. Okay, so how it will be? A XR. If any one of one is value is 1, 0 1 1 means 1, but 0 0 0 only, 1 1 also 0 only, 0 0 also 0 only, means any one of the value is 1, then only it will be 1. If both are same, then it will not consider. 1 means what? 1. A XR B is equals to 1. This is how you need to calculate. Okay, now tilde A. Okay, so before that, we'll discuss that later. So left shift operator, A less than 2. Okay, here you will have only one operand, not 2. Okay, so here A, now A is what? A is 0 1 0 0. Okay, left shift means you need to, how it will be, these things you need to move left shift. Okay, so how we can write this one? If I take something like this table, this 0 value comes where? This 0 value comes here. You need to leave these two. If it is 1, you need to leave 1. So this will go here, this will go here. Okay, now what happened? And this will go here. Now it is 0 1 0 0 0 0. Right, so now it will shift to left side, it will shift to 2 bits, so it will leave these to this one. So if you see this one, in the first one, 1 2, what is that? 4 8 16 32. So 1 is there in the 16. So A lift shift 2 is equals to 16. Okay, we are just shifting 2 bits. This first value become left side 2 shifts. So I'll leave these two. I'll put here. I'll put this one here. It will become 2 bits before, no, this one, this direction. So in this position, what is there? We have 1 2 4 8 16. So in this position we have 16. So because of that, A left shift 2 is equal to 16. Okay, so now we'll take A right shift 2. Okay, what is that A first? 0 1 0 0. Right, same 4. Now it is right shift. Okay, let me take like this. So these two things will go somewhere here outside. So right side, this value become in the first position 1. The remaining things, if it come also, all zeros. Now what it became? 0 0 0 1. The first value 1 means what? It is 1. So is equals to 1. A right shift 2 is equals to 1. You need to, you leave these two, put outside, means right side, right? So put outside, then the first value, this third value will become in the first value here. So that's how it will shift. Okay, if it will shift like that, this one came in the first position. This one means what? this one. Okay, first position is 2 to the power of 0 means 1. A right shift 2 is equals to 1. Okay. Now we'll talk about the tilde. So apart from that, we have some what do you say? Some shortcuts also. Sorry, no, can't do that. So we have some shortcuts. A left shift 2. Okay. A left shift 2 means what is the formula for this? 2 to the power of n into A. Okay. 2 to the power of n is what? N means this value. 2 to the power of 2 into A is equals to what? 4. 2 to the power of 2, 4. 4 into 4 is equals to 16. Right. A left shift 2 became 16. At the same way, we'll talk about this. A right shift 2. Okay. What is the formula for this? A by 2 to the power of n. What is A? 4 by 2 to the power of n is what? 2. So 4 by 4 is equals to 1. Right. We have got the same one here. Right. This is how you need to calculate this A and B, A or B, A XOR B, A left shift, means whatever it is, B A left shift or whatever it is, binary left shift, binary right shift. Okay. Now we'll talk about tilde A. So for this, let me clear this. So we need to be very careful on this. So A is equals to 4, right? Now tilde. Otherwise, I'll take here 5. Okay. I'll take 5 tilde A. So normally, this is integer, right? Integer means what? 4 bytes. 4 bytes means 32 bits. Okay. 32 bits. In the 32 bits, first bit is most significant bit. They'll say it will represent your sign. This is positive number or negative number. And the remaining 31 will give you actual value. Okay. So if it is 1, it is negative number. If it is 0, it is positive number. Okay. That's how we'll represent. Now, 5 means what? 5 means if you consider 32 bits, this is positive. Okay. 5 will be represented like 0. First one is positive 0, some zeros and those dash. What is that last? 0, 1, 0, 1. Okay. 0, 1, 0. This is how it will represent. Now, what happens? Tilde A, sorry, 5. A means 5. So now it will flip everything. Okay. It will flip everything. So what will happen? This is 1 means 0, 0, 0, 1, 1, 0, 1, 0. Okay. 1, 0, 1, 0 means what? This is 2. This is 8. This is 10 value. Decimal. Okay. This is how you need to calculate. But first we'll try to run the program. What will be the output of this? Then we'll come back here. Okay. So go here. Okay. First we'll discuss, then we'll come. Otherwise, I need to clean this. So, but in real time, if you give this value, if you run the program, it will give you output as -6. Okay, -6. But I'm getting 10 as per the tilde 5. It will flip everything. Okay. So in that way, if you see at least -10 or 10, it will come. Okay. But so Java will consider it is 2's complement. It will give you the output in 2's complement. Okay, how to calculate this 2's complement, right? So first, what it became, sorry, these are all 1 1 1. Okay, it will flip, right? Normally if you take 4 bits, if you perform this one, you will get 10. But if you calculate this tilde 5, we need to consider all these values, 32 bits. In the first value is 0, as it is positive 5. So it will become minus. If you want to make it, if you change it to 0 to 1 flip, it will become minus. Okay, this is minus value. Then first part, what you need to do, you need to calculate first 1's complement. Okay, 1's complement, what it will become? 1's complement, it will become, again it will flip. Okay, 0 1 0 1. Okay, and then it will 0 0 0 0, something like that. Now if you change 1's complement to second step 2's complement, okay, then you need to add plus 1. Okay, that's how we'll calculate. In the 2's complement, if both are 1, okay, both are 1, it will become 0. Okay, and then 1 will move to here. Okay, then 0 1 1 1 1, as it is, it will come 1 0. Now it became what? 0 1 1 0. Okay, you need to add plus 1 1 1 become 10, something like that, 10. Then we'll give 1 here, 0 here, 0 1 1 1, and now it became 0 1 1 0. If you take 1 2 4 8, something like 2 to the power of 0 something, then one position is there, what? 4 plus 2, it became 6. Already it became minus, negative, so it became minus 6. Okay, that's how it will become minus 6. So if you want to make it simple, 5 is 0 1 0 1. Okay, then tilde 5 means it will become, it will flip. Tilde 5 means it will flip. Flip means what? 1 0 1 0. It is 10. Now if you want to make it 2's complement, okay, 2's complement of 10, how it will become? Again it will become 0 1 0 1, and you added 1, right? So it's tilde, the positive number will become negative number, it is minus 6. Okay, still confusing. Okay, still confusing. We have one formula. Okay, we have one formula. Now I'll give tilde n is equals to, this is positive number. Okay, positive will become negative and n plus 1. Okay, if you want to get the negative number, minus n, then it will become positive, then n minus 1. Very simple. Okay, if you're not able to understand this one, not able to calculate this one, then simple formula. Okay, tilde n is equal to minus of n plus 1. Tilde minus n means plus of n minus 1. First it will symbol become reverse, and if it is positive, plus 1, if it is negative, minus 1. That simple it is. Okay, now we'll take some examples and we'll see. Let me clear this. So let me go back to here. So I have created Bitwise Operators class. So now I will write int a is equals to 4, int b is equals to 5. That's what we have taken, right? Then system dot out dot println a and b. So what we did, that became 4. Okay, so now I'll take a or b. Okay, it became 5 when we calculated. Okay. Now A XOR, that is this symbol, it became what? It became 1. Okay. Now A left shift 2 became 16. Then A right shift 2 became what? This is also 1. Okay. Then again I have taken tilde of B. B is 5, right? It became -6. Okay, -6. And I'll take one more. Tilde of, I'll take -10. Then it become +9. Okay, that is what we have seen theory. Now we'll try to execute this and we'll see are we getting the same output or not. Okay, so let me copy this bitwise operators, and here Java bitwise operators dot Java, and you see here outputs. Let me rerun this. It's not showing full. You see that first one is 4, second one is 5, then 1, 16, then 1, -6, +9. Right. This is how you will calculate these values with the help of bitwise operators. Okay. Now, if you go back, what could be the possible interview questions? The same question, what are Java operators in the high level? And from this topic, they might ask, can you explain Java bitwise operators? Can you tell me how left shift will work, right shift will work, the tilde A work, AND will work, OR will work? Specific to that level also they might ask. Okay, so that's all in this video. Thank you.